So key to solving the howler is going to be reading input files and also writing them. And so we haven't done that yet. So let's spend some time talking about, first off, how to read a file. So there's the name of a file, which is a string, and then we have to open that file in order to read it. And so that's I think one of the hardest things to learn about files and file handles is understanding the difference between the name of a file and the file handle, which is the thing that we're going to use to actually look at the contents of it. So we're going to interact through a lot of this. We're going to use the OS module for, and that stands for operating system. So you may be running on Windows. I'm running this on a Mac. I often run my programs on Linux platforms. In each case, those are the operating system, Windows, Linux, and underneath Mac, I believe it's a version of FreeBSD, which is a variant of Unix. So whatever the operating system is, they all have an idea of a file. So Python interacts with the operating system through the OS module, and it is what allows us to be able to figure out, is something a file or not. So if I ls here, we can verify there is no file called blarg. So if I go into my Python 3 REPL here, and I import the OS module so that I can use it, if I say os.path.isFile, and I give it the name of a file that clearly does not exist, like blarg, then it returns false. That is not the name of a file that exists. I do see that, let's see, solution1 is a file here. So if I replace that with solution1, true, that is a file. So inside the operating system module is another module that we can use that encapsulates a lot of functions having to do with paths, so where things are located on our computer. Inside of that is a function called isFile. So I can learn more about this by saying help on os.path, and it will show me, it says here common operations on POSIX path names. So for instance, it can return base name or dir name. And I wanted to highlight those in particular because if I'm on a Unix system, I can actually, right here and I use the bash shell, I can say dir name for a path that actually doesn't even have to exist. I can say foobar baz.txt, and the dir name is all the directory stuff up until what is called the base name. So if I say base name, that is the baz.txt. So dir name and base name come directly from those kinds of ideas. And so we have those same functions available to us through the OS module. So however, whatever operating system you're working on, it has an idea for the directory name and the base name of the file. And we can actually use the os.path.dir name function, and we can give it foo bar baz.txt. And note that this doesn't actually have to be a file, a real existing file. There is nothing on my system called foobar_baz.txt. It's just a string that looks like a path, and if we ask for what the dir name is, dir name will tell us. And similarly, if I ask for the base name, it will also tell me baz.txt, exactly the same way that the operating system itself would. So those are a couple of just handy functions that you should probably know about. There's a lot of things that you can learn about the os.path module, and you should read the help for understanding that. If I'm in the main directory, so if I go up here to the main directory of the project, and I go into Python, I go back into the REPL. I need to import the OS module again. From here, I can say, I can establish, I can set up a variable called file or path or whatever you want, and I can say its inputs fox.txt, and now I can say os path is file on that file, and it's true because relative to where I am in this in the directory structure. From here, relative to this, from the place that I'm running this, there is an inputs directory, and inside there is a file called fox.txt. So that is something you're going to really need to know how to use because it's impossible to open files that don't exist, for example. So we have file here. What is file? What is the type of file? It is a string. That is not the file itself. It's just the name of something, and we can verify that that is the name of a file that does exist on our system. But we're not able to see the contents of it using file. For that, we need to open the file, and there's a function called open. And it wants a file name. So if we were to give it, for instance, blarg, which we know doesn't exist, it's going to blow up. There's no such file or directory. We can't open a file that doesn't exist. That's why I was stressing all the OS path is file. But we can open our file that we have and just remind ourselves that file is input.txt. And if I open the file, it's going to return something that is a file handle. Now, I didn't capture that into any sort of variable, so I still can't read it. But if I do this, if I call a variable something like fh, that's usually what I call file handles, now file handle is of the type IO, text IO wrapper. So IO here stands for input output, and text IO wrapper is this basically it's a module that allows us to interact with the contents of a file. So I think of a file handle a bit like a can of tomatoes here. So for instance, if I open the fox.txt, which I have here as the file handle, I can call a method on it called read. And if you want to know what you can do with the file handle, you can say help fh, and it tells us here all the things that we can do with a text IO wrapper object. For instance, we can read at most in characters from the stream, and by default it will just read the entire stream. It will read the entire file, which is perfectly fine for all the input files that I've given you. But you should be aware, and I will stress this many times, if you call read on an extremely large file, if the size of the file is greater than the amount of memory that you have available on your machine, you are in for some hurt. It'll probably crash your machine. Certainly your program will probably lock up, at least for a little while. So here, I'm going to show you how to use the read function. So if I say fh read, it returns the contents of the file. Now, when we look at this, when we used cat on the command line, we didn't see this. This is the way in text that a new line is interpreted, is represented. And then it gets interpreted, so like say by the cat program, sorry, that's my dog. It gets interpreted by the cat program, and we'll turn it into an actual new line. So here, when we say read, what we see is that new line is still stuck on there. If we try to read again, we get back the empty string. And basically that's because we've poured the can of tomatoes out. So we opened it here with using open, it's like using our can opener. And then when we read it, it's like pouring the tomatoes into a pot. We can't pour the tomatoes into a pot again. We've exhausted the file handle. It is possible, for instance, to do file handle seek and tell it to go back to the 0th position, to the beginning of the file, and then you could read it again. But that's not really what we're messing around here with. Generally, I just read a file and I'm done with it. So I'd like to talk a little bit about what comes back from read. That is a string. So if I say open file read, I get back a string. Let's check that. If I say type of open file read, that's a string. And what I'm showing here is that we can actually chain these commands together because the return from open file is a file handle. A file handle has a method called read. So we can just combine them all together, open file dot read. And we get exactly the same output as we saw earlier by reading it by calling fh.read. This is a string, which means that I could additionally tack on any string method. For instance, there's a string method called rstrip that will strip any white space off the right-hand side of a string. So for instance, if I want to get rid of that new line character, I can say open file read rstrip. and now I get back the string without the new line attached. So that is a way. So if I were running this program from the command line, I could type, for instance, this. I could say run, let's go back into the directory, and I could say run the solution here with this as the input. And you see that it prints it in all uppercase as it should, or I can run this with inputs fox.txt, and it does exactly the same thing. Notice here, though, that it doesn't print an extra new line. It prints exactly the right number of new lines. So what I was just showing you with doing open, read, rstrip is going to be important, because when we read the input from an input file, we're going to have to assume that there's probably a new line terminating the text. And so we'd like to remove that from our input file. But if it's coming from the command line, after we type this, we're hitting the return key, which is a new line, and the operating system will remove that new line. So we'd like for our text to look the same, whether it's coming from directly from the command line or from an input file. So we'll talk more about now. Next, we're going to talk about writing files. We just finished up with reading files.